Hi everyone. Today we're going to be going over for loops and arrays. So first, a refresher on for loops. For loops are a way to iterate or run through a set of numbers. The most basic usage of for loops is to generate a list of numbers in some sequential order. Fundamentally, for loops have three parts. The initialization, like int I equals 0 in this example, the condition, which is I less than 5. And this is the condition where when we continue running through the for loop when this is true and stop when this is false. And then we have the incrementation part. This is how we change I after each execution of the for loop. So in this for loop, we're initially setting I to 0 here. Then we're going to stop when I equals 5 because at that point, I less than 5 is not true anymore. And then we're going to do I++, which means increment by I by 1 each time. And within that for loop, we're going to print the value of I. So when we run that, this is what happens. We start I at 0. So we print I equals 0. Then we increment I equals 1. Increment again, I equals 2. Increment again, I equals 3, and increment again, I equals 4. But after I equals 4, we increment I again, I becomes 5. At that point, I is no longer less than 5, so we stop the for loop. Now, let's introduce arrays. So, why would one want to use arrays in the first place? In computer science, an important concept is that of random access. What does this mean? Well, suppose that we have a number of items of the same data type, and we want to access, that is, set and retrieve, any number of these items with a minimal amount of code. A real-world use case that requires random access and exemplifies this is as follows. Suppose that we have a virtual store with a shelf of items, each with a number assigned to them. For example, item 1 refers to chips, and item 2 can refer to salsa, and so on. A customer comes in, gives us a number n, and wants us to retrieve the item corresponding to number n. Let's take a look at some code that demonstrates this use case when we don't involve arrays. You'll quickly notice that this code looks really ugly. We have a function string getItem that takes an argument item. We use a series of several if statements to figure out what physical item the customer wants from the number they provide us. This takes a lot of code and makes it difficult to keep extending the function if we add more items to our shelf. For each object we want to add, we'll have to tack on an extra 2 lines to this function, a line to check whether the number we're given matches the item's number, and a line to return the name of that object. Now, let's look at how to make this code much nicer and more extensible using arrays. We can model the shelf as an array, with each object taking a spot in the array. Notice how we instantiate a new array in Java. We first declare the type of object the array holds, in this case strings, so we use string. Then we use an open hard bracket and a close hard bracket to denote the fact that we're using an array, so that Java knows that we're creating a string array rather than a single string. Then, as before with classes, we write the name of the array, in this case, shelf. Again, like classes, we use equals for assignment, and then new, and then string array, like we're creating a class. Arrays actually have a lot of similarities to classes. We're doing something a bit special with this declaration by naming all the contents of the array beforehand. We start with the open curly brace and end with the closing curly brace and a semicolon, and the contents are denoted by a set of strings, or more generally the data type that the array holds, separated by commas, like so. Note that we don't necessarily need to do this, and could actually name just the size of the array, filling it with empty strings. And the way we do that is, instead of new string and then all of this here, we just use new string of, for example, 5. And that makes the capacity just 5 empty strings. Once the array is declared, we can access an element by using the array's name and hard braces. For example, shelf of 0 represents chips. Shelf of 1 represents salsa. And so on and so forth. We return an element using shelf of item minus 1 in this example to account for the zero indexing that arrays have. So now let's get to the heart of this video, combining arrays and for loops. Together, arrays and for loops are incredibly powerful by combining the random access properties of arrays with the iteration property of for loops. This lets us access every item in an array with only a few lines of code, as we'll soon see. Here's the example where we combine arrays and for loops. As before, we create the shelf array, and now we use a for loop to iterate through it. We use a standard for loop for this, starting the incrementation variable I at 0, and we limit it at shelf.length. Shelf.length is a special variable that contains the length of our array. In this case, it should be 5. By using I++ to increment I, as we demonstrated earlier, I should cycle through 0, 1, 2, 3, and 4. We access shelf at every index I, printing the corresponding value as we see in the console. We print shelf of 0 chips, shelf of 1 salsa, shelf of 2 guacamole, and so on. Let's showcase the true power of combining arrays and for loops by finding the maximum element in an array. We are provided a value, an int array, cleverly named array, which we don't know the contents of, we just know it contains integer values. But for this example, let's pretend it contains values 2, 6, and 3 at positions 0, 1, and 2, and we'll walk you through the example of how we find the maximum element in this array. We start an int value, result at 0. This will be the value that we return later on. We use a for loop just like we did with the shelf above, iterating through all of the elements of array. We check if array of I is greater than the result, and if so, we set results to array of I. Note that we can actually use a shortcut here, combining these lines into a single line by setting result to the maximum of result and array of I. After the for loop is complete, we return result. If you didn't exactly catch how that works, let's look through the example array we created earlier with values 2, 6, and 3. We start int I at 0, and we check array of 0, which is 2, and see if that is greater than result, which it is, so we set result to 2. Then I becomes 1, so we check array of 1, which is 6, and see if that is greater than result, which it is, so we set result to 6. Then I becomes 2, and we check if array of 2, which is 3, is greater than result, which is not true anymore, so result remains at 6. Therefore, we return 6, which is the maximum element in the array. So that concludes our review of for loops and arrays. And as always, I hope you learned something.